Hello people, today we are back with another video. So today it's going to be about the problem of the day. The problem of the day is filling bookcase shelves. So let's try reading the question. I request you people to try the question once by yourself and then you can check this video out. You will understand it better. So I'll directly jump into reading explaining the question. So we are given each book has its own respective thickness and its height, and then it's in the form of an array. So in the array you have a book, its thickness and its height. So same for each one of them. And then there's something called a shelf width. So we have to arrange all these books in a given shelf. So here you can see, uh, I'll try to explain the question directly. So here you can see the shelf width is 4. 1, 1, 2, 3. These are all thicknesses and their respective heights. And then the maximum width is 4. Okay, so just imagine, this question requires a bit of visualization. You have to just imagine how the situation is here. You can see there's a width here. The width is 4. So I'll place the books side by side such that the width shouldn't exceed the width. So imagine this is in the 0th index, there's a book given. Its thickness is 1 and its height is 1. I've placed it here. So it's in the first bookshelf. It has a size 1. I mean thickness of 1 and then height 1. And then I can play. Then if I want, I can place one more book whose thickness is 2 and width is 3. If I can place it right here, but this question is not it does not have a greedy solution. I'll explain why. And what we have to find, I'll tell you what we have to find. So in the ending, we have to find the maximum height. So for example, here 1, here this book 1 is there, its maximum height is 1. And then there are 2 books in the second bookshelf. This has a height of 3 and then this has a height of 3. So the maximum height is 3 from all this. And here I have placed 4 books. And then you can observe that the maximum, the sum of all the thicknesses does not exceed width 4. So you have to place it in such a way. And then the maximum height here is 2. So the sum of all the maximum heights from each bookshelf has to be written. And then that has to be the minimum value. That is what the question is trying to tell. It is the minimum possible height or total bookshelf can be placed after placing shelves in this manner. So this is not, we know that this is not a greedy solution. So we have to use DP here. We'll try getting a recursive solution first. Here, imagine I take 2 and 3. I place the first book here and then I want to place this book of thickness 2 and height of 3 here. If I want to place it here, if I place it here, if at all, then the maximum height of the first one would be how much? It would be a 3, right? And then next, I can place these 2 books in the second row. You can see it, this 2 and 3 indexed. Once I can place it in the second bookshelf. I can even place the fourth index book here because it wouldn't exceed. Then the maximum height would be 3. It would be 3 plus 3. And then the last 2 will be placed and maximum height would be 2, which would exceed the answer 6. So let's try writing the code for this question. So first we'll try writing a recursive solution. Let us check what all parameters are required for this book, for this question. So let's try writing a helper function. So these two are obviously the parameters that are already there. Yeah, let this be SW. These two parameters are there, and what else we need? We need the number of shelves. We need number of shelves that are there. So that each time one fills up, you can add new shelf to keep that count. We need it. And other than this, we need the index to iterate through the whole through the whole input array. And then what else do we need? Shelves, index, uh, and then we need the current height. And then what else we need? We need the remaining value. Like I'll explain. For example, here you can see 1, 1. As I add, now I added a book here of thickness 1. How much is left? 3. So I have to keep track of that also. So remaining width, that I need. These are the values that are required. Alright, let's define our base case. So the base case would be if the index reaches the end of the array, then I would return, what would I return? I would return the current height, right? And then now we have two options, either to add it to this existing shelf or add it to the next shelf. These are the two options. So I'll create two variables. Okay. So the first variable is take. I mean, you take a new shelf. When I take a new shelf, it would be the current height plus. Now let's write the helper function properly. And then SW and then shelves plus 1. I would increase the number of shelves and then even the index would increase by 1. And then what would be the current height be? The current height would be, what would the current height be? I mean, here is a plus. Okay. What would the current height? I'll zoom in. Okay. So index plus 1. The current height would become a 0. Oh no, it would be as it is. And then what is the remaining width? The remaining width would be again SW because we are again starting, we are adding a new shelf and it's starting from scratch again. Uh, the current width would be the books. What would it be? It would be thickness and height. So index and what is the height? The height is 1. So here you can see the indexes here. Its width, I mean its thickness and height 1. And then yeah, that's all. And now one more variable. If we are doing it in the existing shell, I initialize it to max because only if the remaining is less than, only if the remaining is less, remaining width, only if it's greater than or if it is equal to the books and the width, that's the only time we would add elements to our existing shelf. So books, then index, and then 0. This is when we would add something to our existing shelf variable. So normal books SW and then shelves would be added as it is because we are doing it in the same shelf, and index plus 1. And then what would be the current height? The current height would be the max of height and this height. And then what is the remaining width? The remaining width would be SW. It would be remaining minus the books minus this. And then what would we return? We would return the minimum of new. That's all. Now let's try using this function. And then next, what is now the number of shells will be initially 0, the index will be 0 initially. Then what would the current height be? What is the current height? The current height initially would be 0 itself. There's no change in that. And then what is the remaining width? The remaining width would be again the shelf width because we haven't added any elements to our first shelf yet. Let's try running it. Okay. The first test case has gone wrong. Let's see what's the reason behind it. So what we have to do is the shelf width is there. So we have to subtract the width from it because as we add our book to the new row, we have to remove a bit from the remaining width. So what would be? It would be index, and then what is the width? It's 0. Now let's try running it. Yeah. And then now let's try submitting, which will get a TLE. We got a time limit exceeded. Now let's optimize it. Let's optimize it with, let me increase the font size so that you people can see it. Yeah. So now here you can see that two parameters, important parameters are the index and the current height. So the index and the, no, not index and the current height, it should be index and the remaining width. These two are the important parameters. So we'll memorize the solution. Let me create one more vector called dp, and what would its values be? It would be -1 all over. No, it would be a size. What is the parameters here? Here the maximum length is 1000 and 1000. So let's put 1001, and then it will be one. There will be one more vector of like my of size 1001 and -1. Now these two are there. Now let's try passing it through this and shelf width. No, it should be dp. These two parameters are there. Let me pass it through all other ones. Yeah. Now these two are there. And every time let us update the dp of what is index and remaining width. Not this. I update it here. And then every time I check. If at all this is not equal to -1, then I'm going to return this. Let's try running it. Hope I don't get any errors. Yeah. Now let's submit this code. Yeah. Got accepted. You can make the solution more optimized using tabulation, but then I'll do it in another video. Thank you for watching the video. I hope you got the concept. Thank you.